Hi, I'm Dr. Chigluri, Associate Professor of Physics, Institute of Aeronautical Engineering. Today I wish to tell about the definitions and terminology, which is in the Module 1, Crystal Structures. So, here we have questions, that is definitions. We are going to see in the crystallography, that is crystal structures module. So, the first question is, what is crystallography? What is crystallography? So, the study of geometric form and other physical properties of crystalline solids by using X-rays, electron beams, and neutron beams constitute is known as crystallography. So, we are going to study the crystal structures, that is crystal structures in solids. That is crystals itself, we know that two types of crystals are there. One is crystalline solids, another one is amorphous solids. So, in crystalline solids, the atomic arrangement is regular, whereas in the case of amorphous solids, the arrangement of atoms are irregular. So, we can study the geometrical point of view of the physical properties of crystalline solids by using these X-rays, electron beams, and neutron beams is known as crystallography. So that we can define the crystallography as the study of geometric form and other physical properties of crystalline solids by using X-rays, electron beams, and neutron beams constitute is known as crystallography. What is crystalline solids? A crystalline solid is formed by a regular repetition of its building blocks, that is atoms or molecules, in a three-dimensional periodic array. So the examples of crystals or table salt, that is sodium chloride, diamond, snowflakes, metals, ice creams, etc. So crystalline solids is formed by regular repetition of its building blocks, that is building blocks in the sense of atoms. So suppose if we take a solid, crystalline solid, if it is a crystalline solid, the atoms are arranged by regular repetitions. So the parameters, the lattice parameters. So this lattice parameters, that length will be the same when compared to the other atoms repeatedly. So these crystalline solids formed by the regular repetitions of its atoms or molecules in a three-dimensional periodic array. What is amorphous solids? So, materials in which constituents, that is atoms or molecules, are not arranged in a regular manner over a long range. So, there is no periodicity in structure. If periodicity occurs, it must be over a short distance. So, the examples of crystalline solids are glass, plastic, rubber. So, these amorphous solids defined as the atomic arrangement is irregular. Though the atomic arrangement is regular, but it is for a short distance. It occurs only for a short distance. So that amorphous solids which constitutes the atoms are in irregular manner. So the examples are glass, plastic, rubber. Next one, define lattice. Lattice is defined as a regular periodic array of points in space. Each point in a lattice has identical with the surroundings everywhere. So lattice is basically imaginary points on space with a periodic manner. So suppose if we take a solid, in solids, the atoms will be arranged in regular manner. So when coming to the lattice, this lattice is basically imaginary points on space with a periodic manner. So every this is this is imaginary points. So this imaginary points on space represents the atoms in the crystal. The atoms in the crystal. So lattice is imaginary points, array of imaginary points on space with a periodic manner. So lattice is defined as regular periodic array of point in space. So that point represents the atoms in the crystals. So each point in a lattice has identical the surroundings everywhere. So each point, so if we take this point, so this point is identical with the surroundings. So if we take this point, this is identical to the surroundings. Define space lattice. Atom in a crystal is replaced by a point in space. Then the resultant points in space are called space lattice. How basis is formed? So atoms are molecules which are constituents of a crystal material. For example, in a sodium chloride crystal, sodium chloride molecules, group of one sodium and one chlorine atoms forms a basis. So here a group of one sodium and one chlorine atoms forms the basis. So group of molecules called as a basis. So this basis formed the crystal material. What is unit cell? Unit cell is convenient to divide the crystal into small entities. Such small group of atoms or molecules is a well-defined arrangement. These small cells are called as unit cells. So differentiate a primitive and non-primitive unit cell. The unit cell formed by primitives is called a primitive unit cell. A primitive unit cell contains only one lattice point. Only one lattice point. If a unit cell contains more than one lattice point, then it is called non-primitive unit cell. Suppose so this is a lattice. So the unit cell formed with these lattice points. So this is a primitive unit cell. This is a primitive unit cell. If the lattice, this is primitive, that is this unit cell formed by only one lattice point, then it is called as a primitive unit cell. Unit cell contains only one lattice point. So this is not primitive. So as this is formed, this unit cell is formed by only one lattice point, where here in this one unit cell, in this unit cell, it is formed with the two lattice points. So along with the corner points, atoms, there is one more atom which is at the center of the unit cell. So that's why here two atoms are there. The two lattice points are there. That's why this is non-primitive. So more than one lattice point. So if the unit cell contains more than one lattice point, then it is called non-primitive unit cell. So the unit cell which formed with only one lattice point is called a primitive unit cell. What is meant by lattice parameters? So the translational vectors or primitives and interfacial angles are called as lattice parameters. And what are the important parameters that are used to describe the crystal structure of materials? Effective number of atoms per unit cell, atomic radius, coordination number, nearest neighboring distance, atomic packing factor, interstitial space, and density. So these are the important parameters that are used to describe the crystal structure of materials. How can you define the effective number of atoms per unit cell? The effective number of atoms per unit cell is the total number of atoms in a unit cell by considering the contribution of corner atoms and face-centered atoms. So, the effective number of atoms per unit cell is the total number of atoms in a unit cell by considering contribution of corner atoms and then center atoms and also face-centered atoms. What is atomic radius? Atomic radius is defined as the half of the distance between any successive atoms in a crystal lattice. So, it is the half the distance between any two successive atoms in a crystal. Suppose if we take a cube, so cube So in this cube, we have 6 faces. It has 6 faces. So this cube contains 8 corners. 8 corners. So in these 8 corners, each corner contains 1/8 part of atom. Each corner contains 1/8 part of atom. So that the effective number of atoms in this cube is corner atoms and also including the center atoms or face centered atoms. So in this case, if we calculate the effective number of atoms in the unit cell, so here 1/8 part of the atom at each corner, that is 8 corners, is equals to 1 atom. So the effective number of atoms in this simple cubic unit cell is 1. So when coming to the atomic radius, so half the distance between the two successive atoms. So this is the successive atoms, so half the distance. So this is here to here. Suppose the distance is A, so A by 2 or is equals to A by 2 is the half the distance of the two successive atoms. So atomic radius is the half distance between any two successive atoms in a crystal lattice. Then define coordination number, which is denoted with n. So the number of equidistant neighbors that an atom has in a crystal lattice is known as the coordination number. So the number of equidistant neighbors that an atom has in a crystal lattice is known as the coordination number. Describe the nearest neighbor distance to or in the crystal structure. The distance between two nearest neighboring atoms in a crystal lattice is known as the nearest neighboring distance to or. What is atomic packing factor? So it is the ratio between the total volume occupied by the atoms or molecules in a unit cell to the volume of the unit cell. So atomic packing factor is equals to volume occupied by the atoms or molecules in a unit cell to the volume of the unit cell. So it is equals to total volume occupied by the atoms, that is number of atoms into volume of the atom divided by volume of the unit cell. So when multiplying number of atoms into volume of the atom, then we can get the total volume occupied. The atoms divided by volume of the unit cell. So atomic packing factor is the ratio between total volume occupied by the atoms to the volume of the unit cell. Define interstitial space or void space. The empty space available in a crystal lattice with atoms occupying their respective positions is the interstitial or void space. So if in the simple cubic, suppose if there is 52% is occupied by the atoms, 52% of the space is occupied by the atoms, the remaining space is void space. So the empty space available in a crystal lattice with the atoms occupying their respective positions is the interstitial or void space. What is a crystal plane? The plane passing through the lattice points is known as crystal plane. So plane passing through the lattice points. So this is the lattice points. So the plane is passing through the lattice point is called the lattice plane. So these are the lattice planes. What is interplanar spacing? What is interplanar spacing? The perpendicular distance between two adjacent crystal planes is called interplanar spacing. The perpendicular distance between two adjacent crystal planes is called interplanar spacing. So this is a lattice. So here these are the lattice points. Lattice, and each point represents lattice points. So the line passing through the lattice point is called the crystal plane, lattice plane. We can call as lattice plane. So when taking interplanar spacing, perpendicular distance between two adjacent crystal planes. So this is one of the plane and this is another plane. The adjacent planes are this and this. So the perpendicular distance between two adjacent crystal planes is called interplanar spacing, that is D. How the crystal systems are classified? Crystal systems are classified into 7 on the basis of the shape of the unit cell or lattice parameters. Mention the 7 crystal systems. So the 7 crystal systems are cubic, tetragonal, orthorhombic, monoclinic, triclinic, rhombohedral and hexagonal. These are the 7 crystal systems. What is a crystal structure? So the particular repeating arrangement of atoms throughout a crystal is called crystal structure. Define single crystalline solids. A crystallite is a domain of solid state matter that has the same structure as a single crystal. What is polycrystalline solids? What is polycrystalline solids? Polycrystalline materials or solids that composed of many crystallites of varying size and orientations. What is the Miller indices? Miller indices are a set of 3 integers, so named as HKL, which is used to designate 3 different crystal planes in the crystal lattice. Define lattice plane. A lattice plane is a 2-dimensional array of points showing how atoms are arranged in the lattice. What are Miller indices? Coordinates. Miller indices are 3-digit notations that indicate planes and vectors within a crystal. These notations are based on the Cartesian coordinate system of x, y, and z. So the Cartesian coordinate system is illustrated using the 3 vectors x, y, and z. So Miller indices represents the 3-digit notation with the 3-digit notation that indicate planes and vectors within the crystal. How Miller indices are denoted? A generic Miller index is denoted by HKL. If a plane has negative intercept, the negative number is denoted by a bar above the number. Suppose if there is a 4, 6, 3, then it represents with this closed brackets. It represents the Miller indices. So when there is a 4, 6, minus 3, this can be indicated with the bar. So the negative intercepts, these are the intercepts on the axis. Intercepts on the axis. So that the interceptions on the axials, interfacial. So for the intercepts, if we take a plane, so it is intercepting on the x, y, and z. Suppose it is intercepting at 4a, it is intercepting at 6, here 3, 6b, 3c. So that the interceptions on the axis are 4a, 6b, 3c. So in this case we can write 4, 6, 3. So if there is a negative number, so negative intercepts, if there is negative interception occurs, so this can be denoted with a bar. So a generic Miller index is denoted by HKL, that is HKL. If your plane is a negative interception, then the negative number is denoted by a bar above the number. So 4, 6, 3 bar. Like that we can denote the Miller index. Define Snell's law. Snell's law, also known as law of refraction. Law of refraction. It is an equation that relates the angle of incident light and the angle of the transmitted light at the interface of 2 different mediums. So Snell's law states that the ratio of sine of angles of incidence and transmission is equal to the ratio of the refractive index of the materials at the interface. So sin I by sin r, U is equals to sin I by sin r. So what is this sin I by sin r? So angle of incident light and then angle of the transmitted light at the interface of two mediums. So which is equal to the refractive index of the material. So define the refractive index of a medium. Refractive index is also equal to the velocity of light c of a given wavelength in empty space divided by its velocity v in the medium. Define acceptance angle. It is the maximum angle of a ray hitting the fiber core which allows the incident light to be guided by the core. So, if this is the optical fiber, this cladding, and this is core, and this is fiber axis. So when coming to the acceptance angle, it is the maximum angle of IARE hitting the fiber core which allows incident light to be guided by the core. So the maximum angle made with the fiber axis enter into the core and guided by the material. So it is the maximum angle. So I maximum. So acceptance angle is the maximum angle that light made with the fiber axis to enter into the core and guided by the core. So it is the maximum angle of a ray hitting the fiber core which allows the incident light to be guided by the core. Define acceptance cone. It is the cone in which the light incident at acceptance angle or less than the acceptance angle and the light can propagate through the fiber after total internal reflection. Define a numerical aperture. Numerical aperture is the light gathering capacity of an optical fiber and it is given by sign of acceptance angle. So numerical aperture is the light gathering capacity of a optical fiber and it is given by sign of acceptance angle. So if we take a I maximum, it is equals to sine inverse of NA. So when taking a numerical aperture is equals to sine of I maximum. So that's why it is given by sign of acceptance angle. Define a fractional refractive index change in optical fiber. So the fractional index change can be denoted with delta. So that a fractional difference between the refractive indices of the core and the cladding is known as the fractional refractive index change. So the difference between the core and cladding refractive indices. Suppose N1 is the core refractive index and N2 is the cladding refractive index. So then delta gives that the difference between the N1 and N2. How does the refractive index vary in graded index fiber? The refractive index of the core is maximum along the fiber axis and it gradually decreases. Here the refractive index varies radially from the axis of the fiber, hence it is called graded index. give reason for the distorted output. When rays travel through longer distance, there will be some difference in the reflected angles. So, high angle rays arrive later than low angle rays. So, therefore, the signal pulses are broadened, thereby results in a distorted output. How scattering losses occurs inside the fiber? Scattering is a wavelength dependent loss. Scattering is a wavelength dependent loss since glass used in fabrication of fibers. Since the glass used in fabrication of fibers, the distorted structure of glass will make some vibrations in the refractive index inside the fiber. So this causes Rayleigh scattering. When more than one mode is propagating, how is it dispersed? When more than one mode is propagating through a fiber, then intermodal dispersion will occur. Since many modes are propagating, they will have different wavelengths and will take different time to propagate through the fiber. So that's why if there is more than one mode is propagating, there will be intermodal dispersion occurs. Explain about the critical angle. The critical angle is defined as the angle of incidence beyond which rays of light passing through a denser medium to the surface of a less dense medium are no longer refracted but totally reflected. Define a step index optical fiber. Step index optical fiber is a fiber in which the core is of a uniform refractive index and there is sharp decrease in the index of refraction at the cladding. Define multi-mode optical fiber. Multi-mode optical fiber is a type of optical fiber designed to carry multiple light rays or multiple modes simultaneously, each at a marginally different reflection angle inside the optical fiber core. Define refractive index profile in a optical fiber. A refractive index profile is the radial distribution of refractive indices of materials within an optical fiber. Attenuation. Define attenuation in optical fiber. Attenuation of an optical fiber measures the amount of light lost between the input and output. So total attenuation is the sum of all losses. So optical losses of your fibers are usually expressed in the decibels per kilometer. What are the major components of a optical fiber communication system? An optical fiber communication system comprises of transmitters consisting of light source and input signal modulator. Second one, receiver which has optical detector signal demodulator. Then third one is optical fiber. These are the three major components of an optical fiber communication system. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.